Hello everybody and welcome. Happy Thursday. Welcome to math class. Take your seats, make sure you have something to write on, something to write with, and your multiplication table because it will come in handy today. Today we are talking about adding fractions with unlike denominators. It's a biggie. We're going to be spending a lot of time this year and this fall, these next couple of months, with adding fractions with unlike denominators. Okay, so if you don't get it completely today, that's perfectly fine. All right, the idea is we're getting introduced to it and we're going to start practicing it with the idea that by the end of 5th grade, we can do this pretty accurately and pretty comfortably. All right, and then our teaching points are down here, our I cans today. They say I can create equivalent fractions and I can add fractions with unlike denominators. All right, let's get into it. Before we really start with adding fractions with unlike denominators, let's do a little practice in making equivalent fractions. So here's our 3 practice problems up here. 1/3 equals how many ninths? What equivalent of 1 are we going to have to use to turn our 1/3 into ninths? I'll even draw our fraction bar up here for this first one. We have our thirds. I'm going to color in one of the thirds. And we need to know if we're going to turn this into ninths, how many ninths are going to be colored in here? What numerator are we going to be dealing with? Okay. So let's think about, because remember, we're multiplying by an equivalent of 1, which means we're not changing the value here. So what equivalent of 1 are we going to need to use to turn thirds into ninths? We're going to have to multiply each piece by what? 3 times what equals 9? 3, 6, 9. Okay, so we're going to multiply by 3 times 3 to equal 9. And what we want to remember also is, since it's an equivalent of 1, what number is going to be on top? Also a 3. Okay, if we're multiplying by 3/3, we're multiplying by 1. So the value of our 1/3 is not changing. We're just dividing it into more pieces. And then 1 times 3 is 3. And we can prove that with our fractions bar. If we multiply every third and we cut each third into thirds, we find we have 1, 2, 3 pieces shaded in, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces total. Okay, so let's try a couple more here. 1/5 equals how many 20ths? Okay, the way to start here, think about 5 times what equals 20? 5 times what equals 20? And then we're going to use that equivalent of 1. So in this case, let's count, use our fingers. 5, 10, 15, 20. So 5 times 4 equals 20. And we're going to use 4/4 in that case. And then 1 times 4 equals 4. So we end up with 1/5 is equivalent to 4/20. Last one here, 2/5 equals how many tenths? Okay, start with your denominators. How did we get from fifths to tenths? 5 times what equals 10? 5, 10. 5 times 2 is 10. Okay, and then, since we need an equivalent of 1, it's going to be 2 halves. If you put something else up here, 1/2, 3 halves, 4 halves, whatever, it's changing the value. If we were to put 4 halves up here, for instance, what is 4 halves equivalent to? 4 halves is equivalent to 2 wholes, so we're doing 2/5 times 2. We're making 2 groups of 2/5. So it's changing the value of what we have, and it would be 4/5 in that case. Okay? Or an equivalent of 4/5. But here, we multiply by 2 halves, because that's an equivalent of 1, and 2 times 2 is 4. Okay, so we end up with 2/5 being equivalent to 4/10. This is going to be particularly important when we're getting into adding fractions that have unlike denominators, because before you can add, you're going to have to use your equivalence of 1 to make our two addends, our two fractions that we're adding together. We're going to have to make our two addends have the same denominator so we can add them. Okay? We've got to have the same size piece or the same size group in order to add them accurately. So if we had something like, we'll keep it simple here. Let's do 1/2 plus 1/3 equals what? Right? If we were to draw that out visually, here's our two fractions bars. And there's our 1/2. There's our 1/3. Shade them in. Okay? Now, we can't add these two pieces together right away because they're different sizes. So we don't have a consistent group or a consistent measure that our answer is going to be in. What is it going to be in? 1/2 and 1/2? Right? So what we need to do first is we need to get these pieces to be of equal size. We need to have equal or like denominators. So let's think about our halves and our thirds. And let's think back to Tuesday's lesson, let's find a common denominator over here on our multiplication chart. So if I look at the 2's, I'm going to look at the 2's column for our 1/2, and I'm going to look at the 3's column for our 1/3. And what's the smallest number, the number with the least value, that appears in both columns? Let's take a look here. So here's our thirds. Here's our halves. What's the smallest number, because I see a few, but what's the smallest number that appears in both the 2's column, or the 2's row and the 3's row? And I'm already seeing right away, I'm seeing 6 in both. So I know that I can use equivalence of 1 to make both of these fractions into sixths. But how do I do that? I need to know 1/2 equals how many sixths? I need to know 1/3 equals how many sixths? And I can use multiplication for that, certainly. I can also use my multiplication chart. I look here, I don't even need that row. Let's take our halves first. Where does our 6 show up? If I was going to multiply 2 or multiply halves to make them into sixths, I need to multiply by 3. So in our 2's row, our 3 column. So I know halves times thirds equals sixths. So what I'm going to do is I'm going to multiply this 1/2 by 3/3. Two times 3 is 6. I'll scoot this over just a little more. There we go. 2 times 3 is 6. 1 times 3 is 3. So I know if I use my thirds, I cut each piece into thirds, I will have 6 pieces total. 3 of them are shaded in. So now, let's think about our thirds. Our thirds, how do we get to sixths? We multiply by 2, or 2 halves. Okay? So our 1/3 times 2 halves. 3 times 2 is 6. 1 times 2 is 2. And we can see it on our visual here. If we cut each of our thirds in half, we end up with 6 pieces total. 1, 2, 3, 4, 5, 6. And 2 of them are shaded in. So now, instead of having 1/2 plus 1/3, I have 3/6 plus 2/6. Okay, you could erase it like I did, or you could rewrite it below if you wanted to. So I have 3/6 plus 2/6. And now that I have the same size, all I have to do, keep our denominator the same, and then add our numerators. 3 plus 2 is 5. And you can see that visually here. If I I cut this into sixths to match the pieces above, I see 3 pieces shaded in. I see 2 pieces shaded in. When I add them together, lo and behold, I get 5/6. Okay? If it seems like a lot of steps, it is. You're not alone in thinking that there's a lot of steps here, and that's okay. But remembering what it says above, make equivalents first, then add them. Okay, let's try one more before we go to the digital whiteboard. And those of you in the chat, cut it out. I see it. I don't have time for your nonsense, so I'm not stopping everything and admonishing you for being silly in the chat, but stop being silly in the chat. Do math. Okay, let's try one with some bigger numerators than just one piece. Let's try 2/3 plus 2/12. Let's try this one. 2/3 plus 2/12. I picked this one on purpose because the 3 and the 12 are really far apart. So we've got to really do some thinking here. Okay, so let's see what is our lowest common multiple that we can use here. 12, so the 12s go 12, 24, 36, 48. Okay, so let's see if 12, 24, 36, or 48 show up. If not, we'll come back down to the 12s. 3, 6, 9, 12. Ooh, look at that. My 12 is already in as a multiple of 3. So I don't actually have to do anything to this 2/12. Great. That's one less thing I got to worry about. All I have to do now is figure out how many 12s are equal to 2/3. So 2/3 times something, some equivalent of 1, is going to equal some 12ths. So 3 times what is 12? 3 times 4 is 12. 3 times 4 is 12. So I'm going to use 4/4 as my equivalent of 1. 3 times 4 is 12. 2 times 4 is 8. Okay? Makes sense there. So now what I really have, I'm going to rewrite my problem down here. I have 8/12, which is my 2/3, plus 2/12. And now let's add our numerators. 8 plus 2 is 10, and our denominator stays the same for an answer of 10/12. And I know some of you already looked at that and went, wait a minute, we can reduce that fraction, can't we? Do 10 and 12 show up in the same row anywhere? Well, they'll show up in 1, but that doesn't help us. How about 2's? There's 10, there's 12. Since 10 and 12 are both multiples of 2, we can reduce this fraction. So what times 2 is 10? 5. What times 2 is 12? 6. So our 10/12, in fact, because we're now dividing by an equivalent of 1, 10 divided by 2 equals 5. 12 divided by 2 equals 6. This would be our most simple answer, our most reduced answer. 10/12 also is an acceptable answer. It's not simplified because you can divide by 2 halves, but it is an accurate answer. Okay? Either one is acceptable for today as we're getting started with fractions. Okay? Let's go to the digital whiteboard for a few more practice problems. Remember, we're making equivalents and then adding them up. Let's go to our digital whiteboard here. Here's our first one, 1/4 plus 3/8. Give that a try. 1/4 plus 3/8. Find your 4 and find your 8 on your multiplication chart. What common denominator can we use here? Okay, and if you're looking, and you'll notice, and some of you probably already picked this up automatically as you looked and you went, wait a minute, 4 times 2 is 8. So I can just, all I have to do is convert my 1/4 into eighths, and then I can add it up. So 1/4 equals how many eighths? If we know we're multiplying by 2, we've got to use our equivalent of 1 to do 2 halves equals how many eighths? 4 times 2 is 8. 1 times 2 is 2. So we know this 1/4, if we use our equivalence of 1, this 1/4 is in fact 2/8. And now that we have all the same denominator, we can keep that denominator the same and then just add up our 2/8 plus our 3/8 to equal 5/8 as our final answer. Okay, whenever you can get one of these equations with fractions where you only have to make an equivalent fraction for one of them, it just makes our lives easier. So let's do it if we can. Okay, let's try another one. 1/6 plus 3/4. 1/6 plus 3/4. So remember, if you're having trouble finding a lowest common multiple, make sure we go to our multiplication table, look in the 6's row, look in the 4's row. What's the lowest number that shows up in both places? Okay, I've gotten the question before of, do I have to use the lowest common multiple? You certainly don't have to. Okay, but if you don't use the lowest common multiple, you'll almost always have to reduce it to make it as simple as we possibly can. And also, just the bigger numbers you get, the bigger math you're going to have to do. Okay, so we want to make our jobs as simple as possible here by using the lowest common denominator, the lowest common multiple. Okay, so if we look on our multiplication chart, you'll notice that our lowest common multiple is, let me change my color here, is 12. Okay, and I'm seeing in the chat, thank you, 6 times 2. So we're going to use 1/6 times 2 halves to equal 12ths. And then we have 3 times 4, or 4 times 3, I should say. So we're going to use 3/3 as our equivalent of 1 to make 12ths in this case. Okay, so now what are our numerators? Let's start up here. 6 times 2 is 12. 1 times 2 is 2. So we have 2/12ths for this one. And then 4, now we're down here. 4 times 3 is 12. And then 3 times 3, use your fingers if you need to, 3, 6, 9. 9/12. Okay, so now what we're going to do is we're going to rewrite our problem with our common denominators. So 1/6 equals how many twelfths? It equals 2/12 plus, and then our 3/4. How many twelfths did that equal? It equaled 9/12. Now, we can keep our twelfths because we're not changing the size of the piece and just add 2 plus 9. Count on if you need to. 9, 10, 11. To get 11/12. So our final answer, if we put it back up here, is 1/6 plus 3/4 equals 11/12. Let's try one more. We've got for this one 5/6 plus 1/9. 5/6 plus 1/9. Find your 6's row, find your 9's row. What's the lowest number that shows up in both rows? Well, I know 6 times 2 is 12, but 9 times, no, that doesn't work because 9 plus 3 is 12, so that can't be a multiple. 9 times 2 is 18. Is 18 a multiple of 6? 6, 12, 18. There we go. So we know our answer here is, or it could start being, in 1/18. Okay, so now let's make our equivalent fractions. I'll put it off to the side here. 5/6 equals how many 1/18? 6 times 3 is 18. So we're going to use 3/3 as our equivalent of 1. 5 times 3 is 15. So we know 5/6 is equivalent to 15/18. Now let's do our other one. 1/9 equals how many 1/18? 9 times what is 18? 2, yeah. So we're going to use 2 halves as our equivalent of 1. 9 times 2 is 18. 1 times 2 is 2. Okay? So now we know that when we're adding 5/6 plus 1/9, we're really adding 15/18 plus 2/18. So we might rewrite it down here. 15/18 plus 2/18 equals, keep our denominator, add the numerators. 15 plus 2 equals 17. So our final answer, 5/6 plus 1/9 equals 17/18. Okay, a lot of people have, a couple people have asked me, can't you just multiply fractions by each other's denominator in order to make equivalent fractions? And you can. I can demonstrate it with this one, but I do want to show you why we're going for the least common denominator. So if I have 5/6 plus 1/9, you can always do 5/6 times, oops, 9/9 and 1/9 times 6/6. Okay, if you multiply two numbers by each other, that number will always be a multiple of both. Okay, so 6 times 9 or 9 times 6 is 54. Right? And then people are saying in the chat, yes, but then you have to reduce. Definitely, and you will see why here. Okay, let's figure out how many 54ths we have. 1 times 6 is 6. 5 times 9 is 45. So then we have 45 54ths plus 6 54ths. If you're not following along, if you're not trying to do this with me at this point and just watching, that's great, okay? Because this is a less efficient way to do this. And then keep your 54ths, and then 45 plus 6 equals 51. So then you end up with 51 54ths. The problem with that is you can simplify that majorly, okay? In fact, you can simplify that by using, I believe it's thirds. Okay, you divide this by 3/3. 54 divided by 3 is 18. 51 divided by 3 is 17, which we already ended up with over here. So we just did a whole extra step. This one here. Extra. We did a whole extra step just to get back to the same answer. Okay, so that's what happens when you don't use the lowest common multiple. Okay, it will get you the answer. It might just take longer and you'll take some extra steps to get there. And every extra step that we have in solving a math problem is one extra chance to, like, you know, put a digit in the wrong place, or have a math, have it be 56 instead of 54, and then, our answer is inaccurate. Okay, so not only are we trying to be accurate, we're trying to be efficient and do things in as few steps as possible while still understanding what we're doing. Okay, so that's the case with using the lowest common multiple. This version is much simpler. Okay, by using 3/3 and 2/2 to make equivalent fractions rather than 6/6 and 9/9. Okay. Your exit ticket is on Google Classroom. Give that a try. The 6 main problems are going to be a little, on par with what we did in class, and then the 3 bonus problems might be a little bit tougher, but still doable. So give them a try, right? No harm done, no minus points for wrong answers. So give them a shot. Math groups, both math groups today, we are meeting in the Zoom room in, give it 5 minutes or so. And good luck. If you have any questions or want any feedback, you're welcome to drop into the Zoom room. Otherwise, we will see you next on Zoom for PE at 12:30, and then back here at 1:15 for science, where we're going to be diving deep into one particular very, very curious organism. All right, thanks everybody. Have fun, good luck, and I will see you later.